Alright, this week's lab we are going to be doing a bunch of new topics. We will be making internal bits, creating our own tags using internal bits. So booleans, we will be creating a counter. We will be creating two different types of timers, both a retentive timer and a normal timer on timer. And we will be incorporating all of those into a program. We will also be doing some commenting on bits and commenting on rungs as well. So this is our simulation here. You'll see 5 different control panels, a conveyor, and a bunch of guarding with safety doors on them. So 4 different doors, 1 on each side. These safety doors open and close. Okay, so the parts that are a repeat of things you already should know, I'm going to go pretty quick on, and then we will work in detail on the new things for this week. So we're going to start off by just saying, with this start-stop button here, let's make a seal circuit with a start and stop button that's going to run this belt. So we will create that. So creating a new line of code with a start circuit. So a start-stop with a motor. We can do that pretty easily. We should be pretty good at this by now. All of the all of the real I/O tags I've already created for you. So this is start button, start PV. I'm going to copy this tag over here. This one is stop PV. And this one here is called belt motor. And in our seal circuit, this address down here is the same as our output. So I'm just going to drag that tag down here. That is our belt motor. Let's assemble this. And it should now have working logic for the belt motor. Okay, so that is running logic now. So let's look at our simulation here. So I should be able to now push that button and my belt runs. So that circuit seals in, I push my stop button and everything stops. That is my functioning start-stop seal circuit. Now here's what we want to do with this one. We have 4 different safety gates. 1, 2, 3, so 2, 3, and 4. It's 4 different gates and 4 different e-stop buttons. There's one there. There is one right here. E-stop there. E-stop here. And one on this side as well. E-stop right there. So what we want to do is say, if any of these gates are open, have that also stop our belt. Or if any of the e-stops are pressed, have that also stop our belt. So we can do this in several different ways. Let's look at one way. We could do this here. We need to edit this run. And let's say that we need to have, for example, e-stop 1, e-stop 2, e-stop 3, and e-stop 4. We need to have all of those pressed, or all of those not pressed in order for us to be able to run. Now, as you can see, our rung gets pretty big once we start doing that. And on top of that, we also need to have, I'm going to copy all 4 of those and paste them and say we also have to have safety door 1 closed, safety door 2 closed, safety door 3, and safety door 4, all closed as well. So this is basically what I'm asking you to write. It's something that functions like this. So start button. The start button makes a start. The stop button makes a stop. And also, any of the e-stops or any of the safety doors will also make us stop. Now, as you can see, this line of logic gets pretty big and difficult to read. Okay, that is a lot of stuff going on there, but you'll see this actually does work. So we'll close this door, close that door, close that door, close this door, close that door, and now we can run. And you'll see now if the door opens up, that stops us. I have to close that door and push the start button again. Same thing if I were to open up that door back there. That door opening makes a stop. I'm not allowed to start when that's open. So that basically accomplishes what we've been trying to do, but it makes it very difficult to read as well. So there's an easier way to do this, and this is where we start to use internal bits. So the way that a good programmer will write this is we will start to break things down into smaller pieces to make things more easy to understand. So let's add in some new lines here. I'm actually going to locate these above so they flow better. What I'm going to do is take these stop buttons. I'm going to take all 3 of these here, or 4 of them. I'm going to grab those and move them up to this line up here. And delete that here. I'm going to move this to a different line up here. When you do this for yourself in the lab, you'll just be able to write this the right way the first time. I'm just demonstrating this going the wrong way first. But what we're going to do now is, so now we've got e-stop 1 not pressed, e-stop 2 not pressed, e-stop 3 not pressed, e-stop 4 not pressed. That is basically all the e-stops are good. So we're going to have, if all these are good, let's actually create a new internal bit that's going to say all of our e-stops are okay. Now let's actually call that bit all of our e-stops are okay. So let's make a new output here. And so far all of our outputs we've been using are actually real output devices. So they're actually real physical devices that exist on our machine. So this is going to be a tag that does not represent a real device. It only represents a bit that we're going to use internal to our program. So it's not linked to a real physical device. It's just going to be something we use later on in our program as kind of an intermediate device. So we are just going to create, and so here we're just going to write a new tag. So we're going to call this all e-stop OK. And do this. Now you'll see when I create that, this line still has an error. So if I hover over top of this, you see that it says undefined tag. So basically I put in this name here, but this tag has not been created yet. So we actually need to create this tag. Whenever you write in a new tag that doesn't exist in your database, you actually have to create that tag. So the way you do this, if I click on this and then do a right click, you'll see that very first thing up here says new and then the tag name. So if I click on that, it brings up this little window, and this is my window for creating new tags. Now it automatically recognizes that I am trying to use this as a bool, so a boolean, so it recognizes that as a boolean is the way that I'm trying to use this. Now I could simply just say create at this point. I'll show you the two ways to do this. I could just say create and we are done, and that is now been entered in the database. You'll see this error goes away, and this is actually a valid run right now, so I'm good to use that. So I can do that. Let's do another one here for safety door. So I want to make this one all safety doors okay. So I'm going to go over here, create an output, and call this all safety door okay. Create this as a new tag. New. This time, I'm actually going to put in a description on this at the time when I create it. I'm going to call it all safety doors are closed. This is where you actually get to put in your comment that goes above the tag. So you can see that text that I put in goes up there. Now I didn't do that here, but I can go back and add this. So I'm going to click on this. I'm going to do a right click, and you'll see this thing here, edit main operand description. If I click on this, it allows me to now add that text there. So you can either do this when you create the tag, or you can go back and do it later. So I'm going to say all e-stops are okay. So now what I want to do is I now have a bit that's called all e-stops okay, and one that's called all safety doors okay. And I'm now going to add those two bits into here. So I have all e-stops okay, and I have all safety doors okay. And now functionally, this is essentially the same code that I had before. But it is written in a way that is more consistent with the way that professional programmers would write it, and it's written in a way that makes it more user-friendly to use later on if you're having larger programs, and it just makes each line smaller and easier to look at. It's one of the main reasons we do this. So you can see now, if I can run, so I'm running. If I was to open up this door, I'm now not running because I do not have all safety doors okay. And I go back and look at this, all safety doors okay is not on because safety door 1 is open. So if I close this, same thing with if I push an e-stop, I lose all e-stops okay. Pull that e-stop back out again and restart. And you can see how that is being used. So that is a good use of the using internal bits to simplify your programming. The other thing I'm going to do here, I'm going to add one more line. And this is what another thing you'll commonly see. Instead of having this belt motor directly right here, I'm going to put this on another line down here. I'm going to move this output here. And this start-stop circuit, you typically won't drive the output directly with this, the real-world output. But what we will see them commonly do is you'll have a bit here that's called run mode or something like that. So an internal bit that's called run. I'm going to create that tag called run mode. I'm going to call that conveyors in run mode. And I will use that down here as the seal as well. And then I will have conveyor is in run mode. I will have that actually drive the motor, and I will drive this start light as well. And that is a more commonly way, a more typical use of this start-stop circuit as well. This has advantages of basically having start-stop drive a run mode, and then run mode drives the motors directly in case there's some other factors that you wanted to put in here as well. This would be the way that this would typically be done. So we've shown you now how to create tags, how to add comments to your tags. And now let's look at one more thing. Let's look at how to put in a run comment on here as well. I'm going to click out here. I'm going to do a right click. I'm going to say edit run comment. So this is how you actually break up your program into commenting the runs themselves. So I'm going to call this safety devices. So what you'll see, so now I get this yellow banner up here that says this part of the program is safety devices. Here I'm going to call this part conveyors. So edit run comment, conveyor, I'll call that. So that puts this thing here. So when you're scrolling through a big program, you can tell, oh, this must be where the safety devices logic is. This is the conveyor logic, and we'll name each section of our code as we go here. Okay, so that is those pieces so far. Okay, let's move on here. Let's add some more stuff in. Our next line of code, see this warning light up here? Let's have this warning light come on anytime that we open up a door or push an e-stop. So let's do that. So if we open a door or push an e-stop, let's turn on the warning light. So instead of putting in all of these, if any of these are pressed, we already have a bit that summarizes all those together. So we could say if those are not okay, or we don't have all safety doors, let's turn on the warning light. So let's do that. So what we should see from that now, if we push an e-stop, or if we open a door, that gives us the warning light. Okay, so that's good. Now let's move on to using a timer. So to demonstrate the timers, we're going to use this set of stack lights and switches here. So let's create a new rung. This very first one here, we're going to use an input. Then we're going to, on this toolbar here, if we go over to timers and counters, first one we're going to experiment with is the TON. So that is the timer on instruction. So over here, let's call this timer selector switch on. So you'll see this input comes on when we turn this switch over to the side like that. So we are basically going to be timing how long that switch is pulled to the side like that. So whenever this bit is on, this timer will run. So we have added an instruction called a timer. We have to add a tag in here for that timer. So let's name this timer. So let's call it, let's give it something simple. Let's just call it, I was going to call it class timer. So when I enter that in, once again, you'll see that this tag is currently undefined and my rung is in error. I also cannot put anything in the accumulated or the preset here. So until I define this tag, so I'm going to right click on here and say new tag. Notice that it automatically says my data type is going to be timer because it recognizes that I'm using it as a timer. And I'm going to put in a description here at this point. I'm just going to say timer for SS, which means selector switch. And I'm going to create that. Now once I do this, I'm no longer in error. But you can see I don't have a preset either. So I need to enter in a preset value. I'm going to put in 10,000. So remember this is in thousandths of a second. So 10,000 will be 10 seconds. So let's put that in. And let's assemble this. So now what you'll see, when I turn this switch, you'll actually see the accumulated value of the timer start to increase as it counts. And it's going to count in thousandths of a second. Alright, so we are good. Let's watch this go. So I turn it there and you'll see it start to count. That's 2 seconds, 3, 4, 5, 6, 7, 8, 9, and 10. You'll see it actually stops by itself once it hits 10,000. Okay? And then when I turn this back to 0, so if this logic here goes back to 0, you'll see this one actually reset on its own. So that actually resets, the TON resets back to 0 on its own once this logic goes false. So we get a couple of bits that are associated with this timer. So let's watch how these work. We're going to watch how they work by linking each of them to a different light on the stack light. So let's create 3 new lines here. Each one is going to have a different light associated with it. We're going to go timer stack light green, timer stack light yellow, and timer stack light red. And this first one, let's drive this with class, and you can see class timer, which is the name of my timer. And then I'm going to put in here dot. So this gets down to the next level of bits that are below the timer. And if I expand this here, you'll see here's all my bits that are available below there. So the preset and the accumulated, those are both double integers. So we can't use those. Those are numbers. But these three Boolean bits here, the EN, the TT, and the DN. So let's go with this one here first. We'll use the EN. So that is the enable bit. And you'll see when we put this up here, this automatically takes the comment of the timer. Okay? So we can keep that, or we can double click on this and change it. I'm just going to change it so we can tell what it is. So that is timer enable. Copy that and paste it here. Copy and paste here. Let's make this one the TT. I'll make this one the DN. We'll call this one timer timing. And this one timer done. And let's assemble all these. Watch how these work. So the enable bit will be the green light. So enable is going to be on whenever the input that drives the timer is on. And that will always just basically follow that input. The timer timing will be on whenever the accumulated value is actually increasing. So it'll come on when we start counting. It will go off once we hit our preset value. The done will be off until we hit the preset value, and it'll stay on as long as we are at that preset value. Once we shut the timer off, you'll see the done bit go off. Okay, so let's watch this. So we turn this on, and we get the enable and the timing. So those are both on right now as we count up. And then once we hit 10 seconds, enable stays on. So enable is still on after we hit 10 seconds. And now the timer timing has gone off. The done bit has come on. Now you'll watch, these are all just stay on like that, and they'll stay on like that forever. If I shut the input that drives the timer, that goes off, everything goes off again. So let's watch that again. So enable and timing are on right now as our timer value increases. And once we hit 10 seconds, we basically switch from timing to done. And that is how the TON, the timer on instruction, works. That is the most common timer you will ever use. Probably 95% of the timers you will ever use will be the timer on timer. Pretty much the only other one you will ever use. I'm going to do this. Since we started a new group of logic here, let's put a run comment here so we can tell what's going on. All this timers. Let's now go on to the retentive timer. Watch how that one works. So let's start a new run. And this one here, this is the RTO instruction. So under the timers and counters, RTO. And let's create a new tag and call this retentive timer. You can call it whatever you want. I'm calling mine retentive timer. I have to create a new one. I'll put a comment on it right now. Let's also make this one for let's make this one for 15 seconds. And this one is going to be, the tag is called RTO selector switch on. So what's interesting about this one, I'm just going to put a run comment here to break this up. Timers, RTO. Notice with this one, when we run this guy, we are running it, and if we shut it off, it goes back to 0 on its own. The retentive timer, RTO, this one, when we run it, and then we shut it off, it doesn't go back to 0 on its own. It actually maintains its value. And then if we run it again, it continues to count from where it left off. Okay, so that is the retentiveness of it. So it actually remembers where it left off, and it continues to count. So it's a total amount of time that it will count until you actually reset it. That one is very close to being done right now. And it's done. Okay, so let's add in some more instructions for this one. So let's watch. I'm going to add 4 more lines here. So let's put in the call this RTO stack light green. And this is my retentive timer. Retentive timer dot en. And this will be TT. .dn. We'll call this yellow. Call this red. And then there's one other thing. So how do we actually make this go back to 0? So we need to do one more instruction down here. We're going to use this reset button right here. The reset push button. And we are actually going to put in, under counters and timers, you'll see this reset instruction here, RES. And then we're going to put in the same tag name as the timer. So, retentive timer. If we just put in that tag name here, so now pushing that reset button will actually reset the timer. So let's watch all of this in action. Okay, so this is at 15 right now. We've got our red light on saying that we are done. Let's reset it by pushing this button. So pushing that button makes this go back to 0. And let's go. We are enabled and we are counting. If I put that back to 0, you can see that we no longer have any of these on, but we still have a value in here. If I push this button at this time, the reset button, that takes this back to 0. There we go, we're enabled and timing again. If I shut that off, it takes away enabled and timing. We remember our value. We can continue on. So it works pretty much like the timer on, other than the fact that it remembers its value, and then the only way to reset it, so that would reset the timer on normally. This one maintains that done bit even after our logic goes false over here. The done bit is still on in this case, so we have to actually hit that reset button to take that back to 0. Okay, so that is the retentive timer. All right, final piece we're going to do here, we're going to use this counter. So let's add in some more logic. Counter works pretty similar to the way that a timer does. So again, under here, we're going to do the counter up. Counter up is the most common one we will use. And we need an input to drive it. Create a new tag here. This time I just clicked on new tag, and I'm actually just going to put the tag name up here. I'm going to call it up count. We'll call it count how many. Just do that. We're going to put in a preset value of 5 on here. And this is going to come from the count selector switch on. So what we will see let's put a comment on this, a run comment. I'll just call this counter. That's my counter logic. So basically every time I turn the switch, my counter is going to increment by 1. And you see me holding that there. It doesn't just keep on counting. It actually has to go from this position. The input has to go from 0 to 1. So it's only on the positive transition of that input that it counts. And then once we hit 5, that counter done bit comes on. So let's watch that go. So let's add 2 lines here. So let's add 1. Watch the done bit. So this is called up count dot dn. And this is going to be count counter stack light green. Let's use the green stack light when we're done. And then we'll use this same reset button. Oops. And Let's drag this tag down here. So that reset push button is going to do a reset of this count. So that's counted to 5 right now. One thing you'll see with the counter, you can continue to count past 5. The done bit just stays on, but it will just keep on counting forever. I want to say it's not going to count forever, but it's going to count extremely high. Okay, and then that resets it. So we count. There's a count of 2. Push the button to reset. That takes us back to 0. So we have an action that does a count. And we have something that triggers that reset. That brings us back to 0 with the counter. And we can utilize the done bit to do something. Okay, so that is our lesson on creating tags, creating run comments, creating descriptions on address descriptions or tag descriptions, how to create a timer on, a retentive timer on, and a counter, and how to use those all, and how to create some internal bits, and how to use internal bits as well. Okay, the final part coming up. Okay, so this is the final part of the lab. So here what we are doing, we have a conveyor system. Over here we have 3 boxes. Each one has an e-stop on it. We have start-stop buttons. And our goal here is to run this conveyor with the start-stop buttons and make it stop on there are a variety of factors that will make it stop. So you could make it stop by the e-stop button, by the stop button, or 2 other things. One would be if the conveyor runs for a certain amount of time. I'm running this at 60 seconds, so if the conveyor runs for 60 seconds on its own, it will stop automatically, and we'll see that come on in a second here. Or the other thing would be if it counts 10 tall boxes going through this arch here. So we count tall boxes with this sensor. So if there's 10 tall boxes that come along, that should also make it stop automatically. Okay, so this is going to stop on its own in a minute here. And the reason it's going to stop, I believe, coming up, mine is going for 55, 56, 57, 58, 59, and 60 seconds. So that timed out after 60 seconds. It stopped on its own after 60 seconds. So that's one of the stopping factors there. So this is implementing a timer, a counter, and a couple of internal bits to make this all program easier. If you use a programming pattern, kind of like I've done here, where I'm basically summing up all of my starting conditions, all of my stopping conditions together on one rung of logic, and then making a seal circuit that involves start conditions, stop conditions, that drives run mode, and run mode is my seal. And then from there, run mode is what makes my motor go. And then I'm timing and counting those events that I need to time and count. If you do these things, this programs pretty easily after that. Okay, so that is your bonus challenge for this week. So good luck with that. And that is it for lab number 3.